Well, welcome. My name is Mr. Murphy, and I'm going to be teaching you this lesson about lesson 6.4, where we're going to be focusing on identifying some key features of logarithm functions and how to graph transformations of logarithmic functions. But first, let's look at this example here, y equals log base 2 of x. Now, we're going to graph this, but if you're using a TI-84 calculator, you're not going to be able to put this in your calculator. If you're using a TI-Inspire calculator, you just be able to go in the graphing function, and when you type the log button, you're going to have the option of putting in any base, and so you could put a 2 in as your base. But if you do not have a TI-85 or TI-Inspire calculator, which I know a lot of you guys do not have, which is totally fine, we're going to need to use our Desmos calculators. So let me show you how to do this on our Desmos calculator, and then I'll have you see if you can identify the domain, range, and y-intercepts and the asymptotes and end behavior on your own before we try going over it together. All right, so if you're not already familiar, you would go to www.desmos.com/calculator to be able to access this screen. And so what we're going to do is if we type in just log, again, it's not going to, I'll just show you. If I just type in log, my cursor is right here. So if I want to do log of 2, that's not the same. Log of 2 and log base 2 are two different things. So we need to figure out, well, how do we do a log with a different base? Well, here's what I want you to do. If you go down to the bottom of your screen, there's a keypad button here. And if you open that up, at first we don't see anything that's going to be of use. But if you go over here where it says functions, if you go right here and click on that button, we have different kinds of functions. Yours might be defaulted at trig or one of these other spots. But if you go down to the end where it says miscellaneous, and now we can see at the bottom here, we do have log, and now we have a log base A. So if you click on that button, now if you notice the cursor is down in our base. And so now you can put log base 2 and put x here. So that is the shape of the log base 2 of x function. So I want you to pause the video and I want you to go back to your notes and I want you to find those different features that we need to find, like the domain, the range, the asymptote, and what the end behavior of this graph would be. So why don't you guys go ahead and pause the video and try to answer as many of those pieces or find as many of those pieces as possible. So these are those things that I was referring to that I want you to find. So again, go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how much of this you did. Even if you weren't able to get all of these, hopefully you were able to get some of them, at least the domain and range and the different in the asymptote here. By the way, it should say x-intercept, not y-intercept. But if you notice, the domain there for, again, we're looking at y equals log base 2 of x, which is the blue graph, the one that we just did in Desmos. So if you look at that graph, the domain goes from 0 to infinity. And the range goes from negative infinity, because there is no minimum point, so it goes from negative infinity all the way up to positive infinity. The x-intercept, again, that should have been x-intercept, not y-intercept like the previous slide, but the x-intercept would be at the coordinate 1, 0. Or you could have said the x-intercept was 1. Now the asymptote. The asymptote, as a blue line, you see that it bends towards the y-axis. And the y-axis is the line x equals 0. So you could say the y-axis or x equals 0 would be that vertical line. So let's look at the end behavior. So the end behavior, remember we have as x approaches 0, you could do it in any order, but as x approaches 0, y is going to be approaching negative infinity. So the left side of the graph is not approaching negative infinity along the x-axis. Because along the x-axis, as you go towards the left, we don't go beyond 0. Okay, so we would describe the end behavior on the left side is as x approaches 0. As x approaches 0, the y values are going infinitely down. So the y values are heading towards negative infinity. Now the right side of the graph is approaching positive infinity. Because the right side of the graph on the x-axis, it just keeps getting bigger and bigger and bigger. And those in the y graph, or the y part of the graph, or the vertical part of the graph, as we go to the right, you can see that vertically the graph is continuing to go up. So we would say x approaches infinity, y is approaching positive infinity. So hopefully you're able to get a lot of those pieces. But if not, make sure that you get that in your notes. All right, now I want you to try these two on your own. Y equals a natural log of x. Again, you just type in ln of x on your graph. You could do that on your TI-84 calculator, or you could do this in Desmos if you prefer to use Desmos. But now log base 1/2, you're going to have to do that in Desmos. And by the way, if you type it in as a fraction, 1 divided by 2, it's not going to work out either when you're in Desmos. And so just go ahead and change the base to a decimal when you go to graph that second one on Desmos. So when you go to type that in, do log with the base 0.5 of x, just like I showed you. And if you wanted to see how to do that, you want to just backpedal in this video and see where that little button is at the bottom and how to access those functions for changing the base on a logarithm in Desmos. So go ahead and pause the video and try to find as many of these pieces, these different properties as possible with the domain and range and the x-intercept and the asymptotes and end behavior. And we're going to look at some similarities and some differences between these two graphs. So go ahead and pause and hit play when you're ready to check to see how much of them you got right. All right, let's see how you did. So first off, let's look at that first example, y equals a natural log of x. So you can see there that the domain of that goes from 0 to infinity, and the range goes from negative infinity to infinity. And let's jump over now to graph B. Graph B, even though the graph looks different, because you notice they just flipped or reflected over the x-axis there, even though they're flipped, it still has the same domain and range. The domain starts at 0. There's no values less than 0. There's no values at exactly 0. So it starts at 0 and goes to infinity. And the range still goes from negative infinity to infinity. Remember, when you're describing your range, we always start with the smallest value first. And since there is no minimum value, we start by saying it goes from negative infinity to positive infinity. So make sure you don't just say, oh, it goes from infinity to negative infinity. That is wrong. All right. Let's look at the x-intercepts of both of these. If you notice, both of these graphs have the same x-intercept at 1, 0. It's important to note. Also, both of these graphs have a vertical asymptote at x equals 0. Or if you said the y-axis, that's fine, but it's more mathematically correct, especially with some of the other stuff we're going to be doing here in just a minute, with translating the graph horizontally, that we make sure that we know how to describe the asymptotes as an equation. So I really want you to be in the habit of writing it as x equals 0 in this case. All right, let's look at the end behavior, because the end behavior is the key difference between these two graphs. Everything else up to this point were the same. So I like to also start sometimes with the right side of the graph. So let's look at the right side of both of these graphs. On the right side of the graph for the first one, as what's happening there is as x approaches infinity, the y values are going up. So we would say y is approaching infinity. For the second one, though, as x approaches infinity, the y values are going down. They're approaching negative infinity. So we would say y approaches negative infinity. All right, let's go back to the first one again. So the left side of the graph on the first one, we would describe as x is approaching 0. We can see that the y values are going infinitely down. So we would say as x approaches 0, y approaches negative infinity. And for the second one, as x approaches 0 on the left side of the graph, we notice that the graph is going up. So we say that y is approaching positive infinity. So hopefully you're understanding now those different properties of logarithms and their graphs. So again, there's a lot of similarities that you're going to see with these, and occasionally we'll see some differences. All right. I want you guys to do this now. On Desmos, I want you to go back, so pause the video, and I just want you to graph log base 2, and then I want you to put x plus 3 in parentheses. That's super important that you do that, because without parentheses, it means something completely different. Okay, so I want you to do log base 2 of x plus 3 in parentheses, so that quantity. And I want you to recognize how the asymptote and x-intercept of the function compare to those of just log base 2 of x. So if you want to do both of them on the same grid, you can do that, so you can compare and contrast those. But I want you to find the vertical asymptote of log base 2 of x plus 3, and I want you to find where that x-intercept would be. So pause the video and hit play when you're ready to check to see how your answers compare to the parent function. All right. Hopefully you did this and you're not just sitting back just watching. Hopefully you're actually being an active participant. So please, you're going to get the most out of these videos if you do that. So let's see how you did. So the blue graph here represents the original function, the parent function. The red graph there represents the translated, the new graph of log base 2 of the quantity x plus 3. So you can see that the graph has been translated to the left. And it should be translated to the left 3 units. And if you recognize, if you go back to the original function, log base 2 of the quantity x plus 3, we've been doing a lot with translations this entire year, both in first semester and what we've been doing even in second semester. And you got to remember, whatever happens with the x, when we're going to translate a graph, just think of it this way. we do the opposite. So if it says x plus 3, sometimes our brains want to say, still even now might say, oh, it's x plus 3, so you want to go to the right. Now we do the opposite with the x. That actually means that we're going to move to the left 3 units, as illustrated in the graph here. So we're going to move it to the left 3 units. That means that everything's going to move to the left 3 units. That means that the x-intercept is going to move to the left 3 units. So now the x-intercept it's not negative 3, 0. It's at negative 2, 0. Because it was at 1. So if we move that point to the left 3 units, now it's going to be at negative 2, 0 would be our x-intercept. And the vertical asymptote, instead of it being at x equals 0, well now if we move that to the left 3 units, it's going to be at x equals negative 3 instead of at x equals 0. So that's how those different properties change as we translate the graph horizontally. So here's what I want you to do. I want you to try these two on your own. You might have to graph these, but you might also want to try them without graphing first. See if you can figure out in your head, using what you've known, what you've learned already in previous chapters. See if you can figure out how these graphs are going to be translated compared to their parent functions. And then you can graph it on Desmos and just see if you've done it correctly. And then come back here and see if what you assumed or maybe what you saw in Desmos is the same thing as what I got. So I want you to pause the video. And I want you to see how these graphs compare. So verbally, I just want you to describe how these compare to the parent function. All right, let's see how you did. Let's start with this first one. So the first one, notice how we don't have x plus 4 in parentheses. That means what you can do is you can basically just put that x in parentheses because that plus 4 is happening outside of or after we take the natural log of whatever x is. So that means that the plus 4 is going to affect the graph vertically. It means that we're going to move the graph up 4 units. We'll just let you know, if we move it up 4 units, that vertical asymptote, if we move it up or down, it really doesn't change location. So this is not going to affect the vertical asymptote at all. So if we did have a question, where would the vertical asymptote be or what would the vertical asymptote be? It would still be at x equals 0. That wouldn't have changed. All right, let's look at the second one. The second one, we have 5 times the natural log of x. Remember, we talked about scale factors in the past. So a scale factor, remember, means, so this 5 means that it's going to be stretched. Now, there's a couple ways you could have described it. You might have said something along the lines that it's being stretched vertically by a scale factor of 5. That would be correct. Or even if you just said that it's 5 times the size vertically, that would be acceptable as well. So hopefully you at least got that first one and maybe even got that second one by remembering what we've done in the past with scale changes. All right, well, that's it. That concludes this first day. So again, this first day, we're just focusing on understanding different properties of the graphs of logarithms and how to translate and do different, even a scale change like we saw in this previous one with logarithm functions. So hopefully that made sense to you, and good luck as you work on your day 1 assignment.